Welcome guys. Before us we have a question in physics under the topic of electricity. Now electricity is one of the key topics because it is always in every paper. Now for those that want online tuitions, please feel free to contact me on this line. Alright, so the question reads: figure B8.1 shows an electrical circuit containing two resistors. So the resistors are there to produce the resistance. So the resistance is just the opposition to the flow of current. So whenever current is flowing through a conductor, it experiences some oppositions. Now, if you look at the diagram that we have here, we are dealing with a series connection. Now, why are we saying this is a series connection? Because the two resistors are connected in one loop, which simply means that the current that will flow on the resistor 1 must be equal to current flowing in resistor 2. So that is one point that you need to have in mind whenever you are dealing with a series connection. So we can say current is equal at all points. So that is under a series connection. Now if current is equal at all points, what of voltage? Voltage differ. Voltage depends on the resistance that we have. For example, the voltage that will be at this point will not be equal to the voltage that will be at this point. So voltage in a series differs. So we'll consider this one as voltage 1, then you have voltage 2 here. Now let's look at the first question. So the first question, question A, on figure B 8.1, draw on the circuit to show how a voltmeter will be used to measure the potential difference across the 6 ohms resistor. Now voltmeter is just an instrument that measures voltage. Then the potential difference is the other name for voltage. And if you look at voltage, we are looking at the energy, and energy is defined as the ability to do work. Now what work is done in a circuit like this one? So the first work that we can look at here is, we know that every circuit must have current, and current moves from the positive terminal toward the negative terminals. So this is the movement of current. Now for current to move, it requires energy. The energy that helps current to move is produced by the voltage. That's why we define voltage as the energy. Now if you look at electrons, they move from the negative terminal toward the positive terminal. So we have two opposite directions of flow. So the flow of current is opposite to the flow of electrons, and we call this as a conventional current. Now the question is we just want to draw a voltmeter. Now this voltmeter is just to measure the voltage that is used by the 6 ohms. So since it is specifically for 6 ohms, then our voltmeter must be put on where the 6 ohms is. So that is what we are supposed to do. So we are going to put our voltmeter on the 6 ohms, and remember that a voltmeter must always be connected in parallel. So this is our voltmeter here. So we've done the first question. Now we move on to question B. Now question B, we are told when the switch is closed, calculate the current through the ammeter. Now the ammeter is connected in series. This is the ammeter. So if it is connected in series, it is measuring the total current, which simply means that question B is asking us to calculate the total current of the circuit. So how can we find the total current? So let's look at the formula. So formula for current is denoted by capital letter I, and can be found, we have voltage divided by total resistance. So we need to have the total resistance. Now if we need to have the total resistance, how do we find the total resistance given the circuit in series? So we have resistor 1 and resistor 2. So we just have to find the sum of the two resistors. Then we'll have the total resistance. So the formula is like this. Total resistance in series is equal to resistor 1 plus resistor 2 plus resistor 3. If, for example, you have another resistor. So what's our resistor 1? Is just 6 ohms. Plus resistor 2 is 2 ohms. So our total resistance will give us 8 ohms, which simply means that the two resistors have been combined to form one resistor. So the circuit is like this time. So that's a view you should have after you found the total resistance. So the voltage is 16 volts. Then our total resistance, if we are to combine the two, we are getting 8 ohms. Then provided the switch is closed. So if they say the switch is closed, it means the circuit is now on. Now what's our voltage? Voltage, you just have to get the total, which is 16 volts over total resistance 8. So if we divide 16 by 8, I'm getting 2 amps. So remember, the units for current are amps. Right, so we are done finding the total current produced by this circuit. Now let's move on to question C. So question C, we just want what is the potential difference across the 6 ohms resistor. So let's say this is point A. Then we have point B. This is our point C. Remember, the total voltage produced by the source is 16 volts. So what the question is asking us is that how much from the 16 volts is used by this part. So let's get the voltage from the 16, the total that is used by the 6 ohms voltage. So remember, the formula for voltage is equal to current multiplied by resistance. So the current, we have it's 2 ohms times the resistor. You use the resistor, the one representing the point where the question is asking you. In our case is 6. So if we multiply 2 times 6 will give us 12 volts. So from the 16 volts, 12 volts is used by the 6 ohms resistor, and we'll call this one as voltage 1. So we have found our answer, but let's look at how much voltage is at point B. So to find the voltage at point B, we are going to subtract 12 from 16 because this is used. So at this point, we are going to have 4. Now, if this is 4, how much was used by 2 ohms resistor? We can also find the 2 ohms resistor, and we're going to consider that one as voltage 2. So say current by resistance. Current is still 2. The reason why we are saying current is still 2 because we said current is equal at all points, or whenever the circuit is in series, then current is the same. Now the resistor is 2. So 2 times 2 is 4, which means that there is 4 volts used by the 2 ohms resistor. So at this point, we are going to have 0 voltage. So the total voltage that was produced by the source is used by the 2 ohms resistor. So that's how we can handle a case like this. That's it for this video. Thanks for watching.